going to be talking about this idea of designing for touch. And to do that, I want to step back a second and look at kind of the different devices that people are using to interact with the internet. And that is, primarily web stuff, but also increasingly lots and lots of different types of applications. So this is generally what the spectrum of computers or personal computers looks like today, right? You have these smartphone things, you have these tablet-ish things, you have laptops, you got desktops. We all probably started out in this sort of area, and increasingly more and more of our time and our work is being spent on this side. And when people try to make sense of all these different devices, one of the distinctions that they draw between them is, well, things over here, these smartphones and tablets, these are touch-based devices, right? So they have different ways of being designed and thought about. And then everything over here is sort of the traditional cursor and keyboard world. And this mindset makes a good amount of sense, because if you look at what smartphones and tablets look like, you've got operating systems like Windows Phone, touch-based. You've got things like Android, here running on the Google Nexus 7 tablet, also a touch-based interface. You have iOS from Apple, also quite popular, here running on the iPad. And so this range of devices is all touch-oriented. But let's look a little further down the spectrum and actually see what else is going on. So if we look at our friends, the laptop, this is the Lenovo IDEA Tab Lynx. Is this a tablet or a laptop? Who votes tablet? Who votes laptop? Who wouldn't buy one anyway? Okay. How about this one? The 12.5-inch ThinkPad Twist. Is that a tablet or is it a laptop? Who wouldn't buy one anyways? I'm teasing. Okay, how about this one? The Ideal Pad Yoga. Why do they call it the yoga? Because it has these yoga moves. It's like... Actually, I don't know if that's the noise you make when you do yoga. My brain goes there, right? You're doing yoga. Here's another one. This is the Dell XPS 12. This one's more like a transformer. It's like... That actually I do know is the noise that transformers make, because I've seen the show like hundreds of times. It's unclear if this is actually an Autobot or a Decepticon, because it doesn't have the little sticker on it. So I don't know. Sometimes you have the stickers that you rub. Have you guys ever had those transformers? You got to rub it to see if it's a Decepticon or... No? Okay. Yeah, going way back here. But anyway, you have this emergent thing. And Intel recently made an announcement that all the new chips that they are releasing, especially in the laptop area, you have to run touch on those machines. So whether or not we think these machines are actually a good idea or not, basically, probably in the next year, year and a half, it's going to be very, very, very hard to buy a Windows box that doesn't have a touch screen on it in the laptop space. Right? So all of a sudden, touch is making its way to laptops. And you can say, okay, well, oh, and by the way, Google also announced their new Chromebook series is now also touch-based. And you may say, okay, well, that's fine. So now we really have to think about touch extending into, maybe this 15, 16-inch realm, right? At least the desktop is safe. Or at least we can still make mouse and cursor things for the biggest screens, right? I mean, who would put touch on like a 20-inch desktop machine? Would anybody do that? This is the Sony Tap 20. It looks like a desktop machine, right? Acts like a tablet that you can draw on. And you think, okay, at 20 inches, this is sort of, can you really make a tablet bigger than 20 inches? Like, would anybody do this? Yeah, people at Lenovo have made one for those who do. This is the Lenovo Idea Center Horizon. It is a 27-inch tablet. Now, if you have one of these things, I'll just let you know that it's got a pretty cool interface, but rabbits are very attracted to these things. So what happens is if you leave one unattended, it's highly likely that a little hopping creature will take it from you, and then you may find them interacting with it later. And it's kind of cool. You can play some games, right? Interact with it, but it doesn't stop there, because this 27-inch tablet is also a telephone. So mom's gonna pick it up. Phone's ringing. Let's grab that 27-inch tablet. chalk up some bills to the chiropractor, set it down, and hey, what's going on? Hi, guys. You'd think the fun ends there, right? But no, after the phone call, you hit a button, and it's the neighbors show up at the door button. So then we're going to take the telephone, we're going to put it on the table, and we're going to create our own little version of Las Vegas. So we'll play the photo swap game, and then instant Vegas. I think they're also going to play ice hockey. There you go. If that doesn't seal the deal for you, I don't know it. So it's kind of fun to laugh at these things, but it kind of doesn't matter, right? Because they're out there, computer manufacturers are making it, people are using them, and it's something we have to think about. And I've been showing a lot of devices that are running the Windows 8 interface, and you may say, well, Steve Jobs would never put touch on the desktop, right? Apple would never do this. Well, again, it kind of doesn't matter because this is the Leap Motion device. This is it's roughly this big. You put it next to a laptop or a tablet, or a laptop or a desktop or anything with a screen, really. And what it does is it gives you gestural control over your computer. So you move your hands in front of it. It sort of senses where the hands are and where your fingers are. And you can do things like draw or browse the web using your fingers. And I don't think it's a coincidence that they've taken this New York Times page and blown it up 3x for the purpose of this demo, because your finger, whether it's touching the screen or whether it's in the air, is just not as precise as a mouse cursor, right? So the kinds of interfaces you would make for more of these gesture-based in-air modes are actually more aligned with the kinds of interfaces you'd make for touch than you would make for a mouse and keyboard. And why am I going through this sort of device landscape for a second? To illustrate, touch is pretty much running the whole gamut of things that people are using to interact with the internet on, right? Whether it's a website or whether it's a piece of software, chances are tablets, desktops, smartphones, phablets, phonblets, whatever kind of thing you want to call these things, have touch enabled. And by the way, cursor and keyboard is something you need to consider for all of them too. But for our purposes, the point of walking through this spectrum is to illustrate that touch really matters today, right? It's not something that's just on the iPhone. It's not something that's just on the iPad. It's coming to every single shape, form, factor of device you can think of. And when you consider things like websites and web pages are running on all those devices, and they've all been designed for cursors, mice, keyboards, all of a sudden we kind of have a problem, right? We need to think about how we design for touch. So what I want to do today is just walk through 3 things around thinking about touch in an interface. And I show some examples and hopefully leave you with some ideas on how to deal with this new reality, the fact that every screen is slowly but surely becoming a touch screen. So this is kind of what a touch interface that I think works well looks like. And I'll explain to you why I think this works well. So if she wants to move this list of photos, she just sort of lifts it up. Wants to see what's inside there, she's just going to expand that list. Again, push it up, see what's inside. And notice there's no button or scroll bar or anything like that. All the interactions are with content. If you want to see one, you touch it. If you want to move it out of the way, you move it out of the way. And that's a very different kind of interaction than what we generally have on the desktop, which is, if you look at a high level around what's going on with touch interfaces, it's the content that's the interface. Right? All her activity was, if she wanted to move the list, she actually touched the list itself. If she wanted to see what was in that quote-unquote folder or pile of objects, she expanded that pile of objects itself. If you wanted to see what one is, you touch it. If you want to move it out of the way, you move it out of the way. So it's really about direct manipulation of the actual content as opposed to a lot of playing around with Chrome. And if you look at some of the principles underlying designing for touch, right, they really emphasize this. You want to get out of the way between people and the content they want to interact with. And that includes things like excessive visuals. And in order to make these things sort of work, a reliance on physicality and sort of predictability through what we know in the physical world tends to help you out a lot, which is why things use natural scrolling, right? The way you would actually move something in real space versus the type of scrolling we're used to in computers. It's sort of reversed. And a lot of this is a big change because if you go and look at what's been happening with sort of the graphical user interface paradigm we've had for, what has it been now, 30-something years, 35 years, something like that, right? The graphical user interface paradigm is windows, icons, menus, pointers. In other words, it's very heavy on sort of user interface Chrome. The way you get things done is you click on buttons, you use pointers to point at things. Things sit inside of windows. How much time do you spend futzing with this stuff and this stuff on a daily basis, right? Let me move this window. Just sitting around interacting with all this UI Chrome instead of actually interacting with the stuff you care about, the content. So if that's been the pervasive paradigm of graphical user interfaces for all these years, when you get in the touch world, it's a different set of concepts. And Windows icons, menus, pointers is sort of abbreviated as WIMP. I don't think there's a very good abbreviation for this. KDGF. It's pretty terrible, right? If anybody's got something better, I'm all ears. But what KDGF is it's all about the content, right? It's not about the Chrome. It's not about Windows and things like this. And it's about directly manipulating that content, touching that content, interacting with it through a set of gestures. And because you're directly interacting with the content, the idea of feedback becomes really, really important. How do I know if what I'm doing is actually taking any kind of effect? When you touch something in the real world, right, you sort of push it, you get immediate feedback. It starts to move or it doesn't move. You get pressure on your finger. You get all kinds of feedback from those interactions. And we don't really get that on a flat screen. So we have to account for that in a lot of our interfaces. And so these are kinds of the things that you think about at a very high level in the same way when you think about graphical user interfaces, you think about windows, icons, menus, pointers. Now, because touch is a human-driven sort of input model, right, we actually have to look a lot at human ergonomics to consider how to design for it. These things are the high-level principles behind stuff, but to get a bit more pragmatic, what we actually have to do is figure out how can our fingers interact with stuff. And our fingers are sized a particular way, and as a result, we need to make things work. Now I'm going to point to the Windows Touch Target Guidelines because I think they're in a very interesting predicament relative to some of the other operating systems out there. If you look at what iOS is doing, and if you look at what Android is doing and all these guys, they basically are touch from the start, right? They're touch-based operating systems. The mode that Windows is going in through all these hybrid devices and through other kinds of devices that are out there that they put Windows on now, they live in sort of a dual world. And it's interesting to see how they think about touch targets. So looking at the guidelines that they put out, they have this sort of minimal control size to make with something what they call touchable. That is, you can actually hit it with your finger without lots of errors and problems. And what does that look like? Well, if you look at a standard Windows dialog, this is sort of what it looks like. This is the process of making it touchable. Yay. Who's unimpressed? Right? This is what I say. This is the bare minimum kind of thing you have to do so that when you try and touch this, you can actually somewhat hit it. But if anybody's used a touch interface, this doesn't really sing to you, does it? That's why they have this other idea around touch enabled. And touch enabled, you can see, is actually much bigger. By the way, we'll talk in a second about why I'm using physical measures here versus pixel measures. But touch enabled, as you can tell, is actually a much bigger deal. And in both of these, they recommend using minimum spacing of about 2 millimeters between targets, because having a gap between stuff means you don't accidentally hit the wrong thing when you're trying to touch it. Now, why do we care about touch target sizes, right? Why is this one of the key things? I mentioned our fingers are bigger than our mice, and I've sort of teased this, but here's some actual data that illustrates what's going on. If you look at the size of a touch target and you look at how many errors happen, you'll notice that right around 5 millimeters, it just goes crazy. Spikes up, right? 20% mistaps. And can you imagine 20% of the time you're making a mistake? Think about how frustrated you would get, right? I mean, I think it's even frustrating if 5 to 10% of the time you're making a mistake. Consider how many actions you do on a computer on a daily basis, right? And imagine if tenth of the time you were making a mistake. You would go mad. So what you really want to do is keep it like here. You want to keep it sub like 1%, right? Hence why 10 millimeters is actually a good range. And where does this 10 millimeters come from? Well, there's a bunch of studies done around human fingertips and human finger pads. And the average human finger pad is 10 to 14 millimeters, and the average human fingertip is 9 to 10 millimeters, hence why this 10 millimeter range kind of comes out. And there's a number of situations where you actually want to make things bigger, physically bigger. Like if something is frequently used, you may want to make that larger than 9 or 10 millimeters. If the result of touching something could be a big error, you might want to make it bigger. If it's located towards the side of the screen, if it's part of a sequential task. There's a number of reasons why you might want to account for that. And 10 millimeters, 9 millimeters, this sort of range right here is actually quite big on a screen. When you lay it out on like a desktop computer, it feels really kind of chunky, almost Fisher-Price-esque. But then when you put it on a touch screen and actually start interacting with it, it feels very good. And the reason for that, this is the data that I think actually sort of seals the deal for me. This is the average index finger width. That's a baby's index finger, right around 7 millimeters or so. So most of the websites we have out there right now are not even good enough for a baby's little finger to tap appropriately, much less a basketball player or someone with much larger fingers. So we care about touch target sizes because, again, we care about human ergonomics. And that's one of the things that really comes out of designing for touch. We are really having to bring people more into the equation than we had to previously, right? Previously, people's sort of metrics were proxied through a mouse and cursor and sort of rationalized down to, okay, I don't care if you're a baby or a basketball player, you are a mouse cursor to me. So we've been objectified like that for many years, and now we get to be ourselves, and it turns out ourselves are pretty different. So we need to account for that. Now back to the Microsoft example again, because I want to sort of illustrate this idea of just not going far enough with this. And there's no better place to sort of show this transition from a keyboard and mouse world to a touch world than in a place where they both live, which is what's happening with Windows 8. So in a keyboard and mouse world, Microsoft is basically saying 5 minimum controlled size, 7 millimeters recommended size, 10 millimeters, things that get hit very frequently. In a touch-first application, they're saying 7 millimeters is the minimum size, 10 millimeters is the recommended size, and then plus if you're doing things that are commonly used on the edge, whatever. And in all cases, it's 2 millimeters. So let's visually look at the difference of this. If you take this keyboard and mouse first sort of interaction, this is what Microsoft did with their Windows Office suite. Have you guys seen the ribbon? So this is the ribbon for a traditional keyboard, mouse, cursor interaction. This is what happens to it when you put it into touch mode. Again, I mean, it's like, okay, right? They made it a little bit bigger. Well, so if you have a keyboard and mouse, let's look at another example, right? So here's like their little contextual panel for editing text. Here it is in touch mode. I mean, granted, it makes things better, right? But it's not really designing things for touch first. What it's doing is sort of like stopping the bleeding. And so if these keyboard mouse first designs and the padding of these elements, I think what you're literally doing is stopping the bleeding. Like, okay, well, we'll cut down errors a little bit by just making things a bit bigger. That should help a touch. Contrast that to the way they're designing applications for touch first. And you'll see that these things look really, really different, right? And the control panels come down from the bottom, whatever. So this is what would be considered in their guidelines more of a touch-optimized interface. And so I did this little project for Intel that I'll show you guys. And what we did is we took an existing desktop application. In this case, it was called Twister. It's the ultimate social networking tool for the storm chasing community. Because everybody needs a social networking tool, right? Especially if you're chasing storms. What better way to do that than with friends? But what we're going to do is assume that Twister is an existing standard desktop app, right? Something you see all the time and perhaps cringe around. And what we're going to do is adapt it not to be touch enabled, not to just do this minimum threshold of let's make the controls a little bit bigger, but let's actually turn it into something a bit more touch optimized. And when I talk about this process, and again, I talk about like desktops and laptops moving to touch, a lot of people say, well, why would I use touch on my laptop? Doesn't make any sense. You know, I would never do this. And that was actually my first reaction to a lot of this stuff. I thought, you know, why would I move my fingers to the screen? I've got the mouse and keyboard. I'm totally comfortable doing this. And then I actually got one of these early prototype Ultrabooks from Intel, and I realized that the vast majority of things I was doing was with touch. And then they shared some data with me that actually backed this up. And the data that they had when they did some testing around these early touch-enabled laptops was that more than 3/4 of all the interactions were coming from the touch screen. Then the mouse, a little bit of the keyboard, and then last but not least, the trackpad. And when you actually start to think about this, it begins to make sense, right? What happens is the touch screen is for the majority of stuff you do, like scrolling and tapping things. Super easy. The mouse is when you need to get a little bit more precise. Keyboard is when you need to type something. And then trackpad is, I don't know, sort of no man's land to a certain extent. Those things are never really great. Anybody use a trackpad like all day, and by the end of the day, you just feel like you need a new hand, right? It's pretty painful. And people were actually really excited about this, having touch on laptops. So while my initial reaction was, this doesn't make much sense, and while I think a lot of people's initial reactions are like that, there's something there. There's something when you put this capability on a device that gets it going. As a result, I think it makes sense to look at what this transition could look like. So Twister, social networking for the storm chasing community. Here's what the desktop version looks like, right? Here's your feed, what your storm chasing buddies are doing. Here's sort of a blown up view of one of those updates. And you'll see some common things to a desktop application, which is you've got these small targets really designed for the precision of a mouse cursor. And you know, this is a pretty simple app, but remember our Microsoft Office example where there's like 100 things just in one instantiation of the ribbon? A lot of small targets. And another characteristic is there's lots of UI Chrome. So if you want to interact with like a photo gallery, there's a whole bunch of controls for interacting with that photo gallery, right? They're made very visible. There's like 10 buttons, so on and so forth. So if we go and shift this over to a touch optimized sort of interface, and since we're in the Windows world still, what we'll do is kind of put it into the Windows 8 style framework. This application could look a lot more like that. And we've taken those little small conventions off the desktop that were up at the top, and we've turned them into really large touch targets on the right side. You can see you can't miss hitting these sorts of things with your fingers. And you'll also note that in a lot of places, we've sort of dropped some of the UI Chrome and made the content the interface. Let's look at one more example in this application to sort of drive this point home. Typical form, right? You guys have probably seen a gazillion of these things. Some of them are maybe the bane of your life because you got to fill them in all the darn time. And again, same deal. Like, look at this capturing location dialog, right? It's just tiny little tickers to move this thing up and down. Everything is sort of driven by text, if you will, right? A lot of text entry, focused interactions. And if we rethink this thing, which what we're doing here is we're trying to capture location and some information about a storm so we can share it with our buddies. So if we shift this over, again, into a touch-optimized world, we're going to apply a couple principles here. And one is around these touch target things, making sure that everything is sized appropriately to interact with. And you see that over here and over here. But the other thing we're going to do is really try and cut down on the amount of text input. And one of the principles that helps a lot with designing for touch, especially on smaller screens, is to sort of think of the keyboard as the last resort. So we got the keyboard up for some text here, but I want to show you this little widget for capturing a bunch of stuff. On these new devices, we can get location, so we'll just automatically feed in location and drop the previous 7 inputs we had to deal with there. But then for entering all this other stuff, we have, grab a photo, grab a video, add some storm data. So if we tap the little touch target sized storm data icon, we get some controls. And this is a little slider, which again is a touch target size thing. And so what we can do is actually slide that over and set the type of tornado we're seeing. So here we're seeing a gale tornado, which is minor damage. But it turns out that while we're typing away, it's actually a bigger storm. It's a significant tornado. So again, just a touch gesture, not typing anything. And then what we'll do is we'll actually surface a bunch of controls here. And yes, we're actually seeing roofs being torn off and trees uprooted, which is why we're on our laptop typing all this stuff in. But you get the idea. I'm not saying this is the ultimate interface for capturing this sort of information, but we're getting as creative as possible about not having everything be text-based, right? Trying to think about, like, how can we simplify the process down so that we can interact with touch? And when people see this sort of transition, so let me actually show this transition again. Like when we go from this kind of interface with lots of stuff on it to this kind of interface, a very common thing that people bring up is, but I have so much stuff, right? If I'm trying to take my existing website or application and make it touch and make it all big, I can't fit everything that I have on here anymore. Yeah, that's awesome. Because you probably got way too much stuff. And one of the things that I really like about designing for touch is it forces you to simplify. Because you can't fit everything on it anymore, right? You have to kind of consider what's most important, what's secondarily important. Maybe you do things that are a bit more progressive disclosure or what have you, like we showed with that little storm form. And the main reason why leading with touch is a good idea, because the big targets that we've been talking about will work for mouse, but small targets won't necessarily work for touch. So this methodology, I think, is not just good for making sure that everybody can use it with whatever input format they happen to have, but I think it also sort of pushes you towards better designs a little bit. Because by virtue of trying to make everything touchable, you can fit less stuff, which means the interface kind of gets a little simpler, which means you got to think about what's really important and what isn't as important. That is, what can either go away or can be behind a tap or what have you. So the touch target story, we have fingers. There are certain sizes. We have to make sure the things we have in our interfaces can be used with those fingers. And that doesn't necessarily just mean the actual targets themselves, but the spacing between them as well. Embrace touch-optimized controls. Sadly, I don't have enough time to go walk through a whole bevy of touch-optimized controls, but there's a bunch of general principles like trying to stay away from the keyboard, and I showed you slider and sort of tap interactions for capturing the same kind of data we were traditionally capturing with the text input form from before. So touch targets is one piece to designing for touch. The other one is touch gestures, which is what are the moves we can make with our fingers. And I'll go through this quickly because if anybody's ever used a touch screen, you know this. So you can tap on things with one or more fingers. You can double tap. Believe it or not, you can double tap with more than one finger, but then it starts to look like a Jimi Hendrix poster. So I wouldn't necessarily recommend this. You can move your fingertip over the surface or move multiple fingertips over the surface, sort of swiping against stuff. You can do that really quickly with a flick. You can theoretically do a flick with multiple fingers, but it's sort of difficult to capture. You can pinch and spread things. Again, there's multiple finger versions of these things. So you have fingers coming together, fingers coming apart. And you have a suite of press gestures, which means you're holding the surface for a little bit, and then you're tapping somewhere or you're dragging around somewhere. A lot of these things are used for sort of system controls these days. So if you have an iPhone and you hold down your finger for a while, it moves into jiggly icon mode, right? Or if you're in a web browser and you hold your finger down, up pops a little menu like save this image, save this URL. Some folks claim that we should really avoid these things because they can accidentally be triggered and they're difficult to time. The general solution here is you just set the timer a little longer, right? So you have to actually hold for a little bit before it goes into jiggly icon mode. I think the problems come in if you make it too quick. And then there's a suite of rotate actions. And the rotate actions, by the way, differ per platform. This is the one that probably has the most variance about how you do a rotation. But it's generally the same sort of spinning pattern. So that's cool. We can make all these gestures. But what we really want to know is how to use them for things. And if you're interested in this, if you go and search for a touch gesture guide, me and a few friends a while back made this thing where we looked at all the gestures that were supported by a bunch of different platforms and mapped them to the most common things they do. So we talked about press. Press was all about changing modes, right? When you hold down, you change modes. If you look at object-related actions, swiping across an object generally is a delete function. And then you have sort of navigation features around how to move things and move through things. So I won't dwell on this stuff. You guys can take a look at it. What I want to do instead is give you a couple little tips and continue with our exercise of redesigning Twister. So in Twister, we had this scrolling feed list. And the way you move this stuff is through usually a scroll bar, which maybe you have a scroll wheel on your mouse or whatever. But you got to position your cursor right over here and start interacting with it like that. In our redesigned version, all you got to do is touch the list to move it up. And by the way, that should work with 2 fingers as well. And then the really cool thing about browsing content like this is you can flick it, and it moves really fast up and down. So you can sort of make your way through that list in a more natural, physical way. And this is where one of our little insights comes out. The Microsoft guys have been talking about this one probably the most. But they have this philosophy of if you have an interaction triggered by 1 finger, putting 2 fingers down or 3 fingers down should probably do the same interaction. Because chances are you may have 2 fingers, right? So like a 1 finger swipe up and down on a list is a scroll. A 2 finger swipe up and down on a list shouldn't be move me to delete mode of everything. Right? Or some drastically different action, right? A 2 finger move to that same list shouldn't be launch rocket ship or whatever, right? Try to be a little bit more tolerant around those interactions. And you saw me show that here in this list, right? If you do it with 1 finger, it's the same thing as with 2 fingers, then you do a quick flick and it shoots back up the list. So that's kind of one thing. Here's another one. So we have this list, and what we can do is any item in this list, we can swipe across it, which is a different kind of gesture. This isn't the same as up, down. This is to the side. And we reveal these little shortcuts for favoriting, sending that, talking to the person. Note that if you tap on one of these updates, you're going to get the same exact controls in this view. So this little shortcut swipe isn't just the only way of doing that, but it's a way to kind of get to that quicker and interact with stuff. And this is this idea that Josh Clark has been doing a nice job of talking about, which is if you think about gestures as keyboard shortcuts, that's what that's kind of illustrating, right? Like as a way to get to things quicker. So it's a hidden thing, but it really doesn't matter if you learn it or not. If you learn it, you're in good shape. If not, you can still get things done, right? So you still maintain non-gesture support, but you can use these little gesture tricks here and there to get people to quick tasks, common actions, or information. Now that we've tapped on one of these updates, we see this nice photo, but where's our UI Chrome? How do I make this picture bigger? Well, you can just make it bigger. And to illustrate this again, I want to show what's going on here. So as soon as you do that, you see that the thing reacts. And this is another kind of key, I would say, guideline to dealing with touch gestures is provide immediate feedback for this stuff. And that can be a color change, a size change, or it can be movement of elements. One of my favorite examples of this is on the Hotel Tonight screen. So they've got this page about hotels, and you can see there's like a little tease of a photo there. And if you just touch it, it starts to react immediately, and you can jump right into full photo mode. Right? So the thing reacts instantaneously. I'll sort of show this example again. As soon as you put your finger in there and you move it a little bit, it starts to react, and now you can flick through it. And here, imagine my fingers on there. And then you move in there, right? But like this idea of immediate feedback that shows you something's touchable and shows you the physics of it is really useful. So we've stretched out our image. Now we're in gallery mode. And we can swipe across to move to the next one, right? Now before I address how do we know that, let me highlight another sort of guideline or principle here. Watch how that thing just starts to follow my finger. Right? So the idea here is if anything can be moved or dragged, it actually starts to follow your fingers. Again, this reaction of immediate feedback. And this really enables this idea for you to browse content. The whole concept of having a large screen that you can interact with your fingers really makes it great for panning and zooming around stuff. And you can also, this is one of my favorite little emerging techniques, you can also sort of see what people are trying to do and use their gestures as they browse through stuff to bring in relevant controls. So this is something that we did recently. It's pretty common that when you're scrolling through a long list of stuff, like so, people raise the question, oh gosh, now I have to scroll all the way back up to the top. How will I do that? Right? It's sort of a pain. Well, those of us that are savvy and use the iPhone, you know you can just tap here and that'll scroll you to the top, or you could tap here to scroll you to the top. Most people don't know that. So what we did is, as you start to scroll up, we bring back the controls that you're trying to get to. So you're scrolling down, and then as we detect that you're scrolling up, we bring in those controls. And the reason why I talk about this is you can sort of use people's gestures as a signal of intent and then bring in controls as appropriate without having those controls constantly be on the screen, especially on small screens where they're eating up space. Well, that still doesn't solve this challenge of how do people know these gesture-based things are possible? This is the #1 thing that people complain about touch interfaces about, right? Okay, so you're using gestures to do this stuff, but now there isn't 5 buttons that tell me what I can do. How do I know what to do? Anybody heard this? Right? One guy? Okay, cool. We'll have drinks later. We can kvetch. So here's a couple ideas around how to discover gestures. And I'll walk through a few of these. So one of the things you can do, and this may seem tedious, but don't show anything else. Just get rid of everything. And if you were faced with this picture, what would you do? You'd probably try moving it. Oh, it works. Okay, I just learned something. Right? So sort of boxing people into the corner may seem aggressive, but it's one way of doing it. Another thing that we can do is tease content. So here we have our gallery. Ta-da, now we have 2 images. I can't see this very well, teased on the sides, which illustrate that there's more to come and you can sort of make your way through it. Another thing we can do is actually show a control and then get rid of it. So when you come here, we'll pull up a little control here that shows you a gallery, and then we'll just get rid of it. And if you tap on the screen, it'll come back up, and you can scrub through it and make your way into this. So we can sort of show some content, get rid of it. Another thing we can do is give you just-in-time interaction, or education. So when you come to this gallery, right when you come to it, we can say, hey, if you want to leave it, just pinch to get out of here. And if you hit OK, and then you pinch, you're out of here, and you learned it. Now, this idea of just-in-time interaction or education is very different from what most touch interfaces do, right? Which is they give you this sort of how-to tour. Quick, how do you remove a tape? You hold the tape to remove it. You just didn't get to one. Here's another one. Intro tours, right? I call these things intro tests. Because like, okay, here's what you're going to need to know to do the application. Now go do it. Oh, you forgot. Oh, you were not paying attention, right? You bad person. So I'm actually not a fan of giving people all these tutorial things up front. Because as I tried to illustrate with my little example, I mean, you look at it, you kind of see it, and you move on, but you don't know until you get there. So instead, what you can do is provide just-in-time interaction. So again, here, you're scrolling through here, you have this vote here, and then we have a gesture control. So after you've done a few things, we bring up a little tip that says, if you're not interested in something, swipe across it. And so now you just learned that you can swipe across something. So we don't show that until you're actually in the process of doing things. Then we bring it up and show it to you when it's relevant. So just-in-time education, I think, is a lot more compelling than intro tests. And on our little gallery mode, when you came in there, we said to just pinch anywhere to leave the gallery. And this illustrates one more thing. You know, you can do the 2-finger pinch, but because we're going to support multiple fingers on the same gesture, you could theoretically pinch it with 3 fingers. And while we're at it, why not? Why don't you just pinch at it with 5 fingers? And this idea of just kind of grabbing at the screen and making it do things is really cool. My friend Joshua was talking about a second earlier, phrases this as big screens invite big gestures. That is, let people use the whole screen as a control. So you can just put your hand on it and go, close, right? It feels kind of sort of physical. Close the thing up. Again, going back to our original principles of trying to make the content be the interaction, of trying to bring some physicality into it. And hopefully that illustrates that there's a couple ways to discover gestures, right? We can remove options to sort of box people into a corner. Sometimes that works well. We can tease things. We can give little cues through animation, or we can use this principle of just-in-time education as opposed to bludgeoning people with these intro tours. The second piece of touch here is these gestures. And I think we're in a point where we shouldn't really be very afraid to experiment. Right? This stuff is still relatively new. It's definitely new on laptops and desktops and things. And so I don't think everybody's figured it out yet. So it's a great time to keep playing with it. But when you play with it, be aware, a gesture is invisible. So some of these discoverability tips that I used might help. OK, to wrap this all up, in the 40 minutes here and actually open it up for some questions, I'm going to do a tad bit of a summary. So touch, pretty much everywhere these days, which means we got to deal with it. And that means if you're making a website, if you're making an application and it's running on something like Windows, or it's running on something like iOS, or it's running on something like Android, you got to be able to design for touch. And that brings up the question, well, OK, how do you do that? Well, the one thing is because we're using our fingers, we got to deal with human ergonomics, so we have to manage touch target sizes, spacing, and those sorts of things appropriately. And that really does force us to simplify stuff, which, again, I think is a good thing. Right? At first, it feels sort of hard, but this sort of reset for a lot of our software interfaces is actually a good thing. And then the second piece is gestures. Whether we're using gestures to browse content, whether we're using gestures as shortcut, whether we're using gestures sort of on a full screen basis, all those things I think can help with the overall interaction design of an application. But we do have to be mindful of these discoverability issues. Right? And so hopefully I showed you some ways to sort of manage that and some ways to not necessarily deal with that. So that's designing for touch. That's mysterious music. And I can field a couple questions.